All right, good morning. Today what we are going to be doing is we are going to be finding the diagonals of prisms by using the Pythagorean theorem, kind of. So, look up please. If I were to ask you to find the diagonal of this box, do you agree that from here to here, I'm going to call that diagonal D, label that D, is the diagonal of the box? Do y'all agree with that statement? Do you also agree that from here to here is the height of the box? Okay, so D stands for the diagonal length, and H stands for height. Now, in order to find D and to do Pythagorean theorem, wouldn't I have to know the diagonal of the bottom? Do I know the diagonal of the bottom? No. But what do I probably know about this box? I know that the width is this length, and I know that this is the length. And what could I do with my width and my length? It doesn't matter which one's the width, which one's the length. Yeah, it doesn't matter. But what could I do with them to figure out the diagonal of the bottom? Not multiply. I could do what? So do you agree, let me just call this x right here. Do you agree I could do x squared? Don't write this down. I'm not writing it down. I'm writing it down on a post-it. I could do length squared plus width squared to figure out that x. Do y'all agree with that? No? Yes. And do you agree that then to find D, it would be x squared plus D squared is x squared plus h squared? Do y'all agree with that? And then do you think I could plug in for this x? Don't you agree I could plug in all of that? Which is where this equation comes from. I like to call this the Pythagorean theorem for 3D figures. For not figures, for 3D, they're rectangular prisms, honestly, boxes. But this will only work for a rectangular prism or a box. I don't want to have you do Pythagorean theorem twice like this says. Do y'all agree with that? So instead, I want you to memorize this equation. The square root of length squared plus width squared plus height squared. W is the width. L is the length. And kind of like Jordan said, it does not matter to me what is your length and what is your width. Those are interchangeable. Okay? So what I may call the width, you may call the length. It doesn't change the answer. Okay? So if you can memorize this, you're only using this when you have a rectangular prism, 3D. Okay? So I like to say this is Pythagorean theorem for three-dimensional boxes versus just a right triangle. So example 1 says the box shown is a cube. What's a cube? Squares, which means the length, the width, and the height are all going to be what? The same. So they're all going to be 8. So what's the tallest then that the item would fit in the box diagonally from point A to point B? So I want to find the diagonal. How am I going to do that? The square root of 8 squared, because that's the length. What's the width? 8. Why is it also 8? Because it's a cube. And what is the height? 8. 8 squared is 64. Oh, by the way, I will count off points. Your square root needs to go all the way to the end of your problem. If your square root stops right here, but you still have numbers, that's points off. Well, don't forget, at the end of your quiz, just go through. At the end of your worksheet, just go through and add them all. It needs to go. So, like, look, if you have it like this, how do I know if the 64 is inside the square root or outside? I don't. Extend it.
When is the read?
I believe maybe Friday. All right, what did you say it was? 192. And what perfect square? Yes. Okay, so hold on. We have 64 plus 64 plus 64. What's another way to write that? That is 64 times 3. No, cubed would be if it was, yeah, multiplying. This is adding. Does that make sense? So 8 and 16 would work, but they're not the biggest perfect square. What is the square root of 64? So this is 8 square root of 3. What's my units? Inches. Now on your homework, it is going to tell you to round. Sometimes, not all the time. If this is the exact answer, write that down. Exact. If it tells you to round in your baby calculator, can I see yours real quick, Cooper? This is how you do that in your baby calculator. You're actually going to work backwards. So you are going to do, honestly, you could do the square root of 192. But you are going to do, there we go, 3, square root it, then multiply it by 8. And what is it? And I think it's going to tell you the thousandths, which is 3 places. So 13.856 inches. This is when I want you to round. So if it says give the exact answer, you're giving me this right here. If it says to round, you're giving me this. Does that make sense? Turn your paper over. I want you to do number 2. Go. Potentially. It just, you have to read the instructions. Here, Cooper, sorry.
This one we do exact?
We're going to do both on all of them, just to practice, yeah. Can I change this? I need to see neat work. I need to see D equals. Yes. I mean, you don't have to, but then you'll just get points off. Look up when you're done. Did you get the same answer as me? Does this divide by anything?
No.
I tried doing all the perfect squares. Did y'all get anything? I didn't get anything either. So we just leave it like this. If it doesn't divide by any perfect squares, don't forget to write your units. That is my answer. Always try that. So 289 is the perfect square, 389 is not. Yeah, be careful. But always try that first, definitely. All right, now if it says to round, put that in your calculator, square root it. What would my answer be? 7230? Right, but after the 3 was a 0? Okay. And this would still be inches. All right. Any questions about number 2? We're okay with 2? All right, last one I'm going to go over. I see people writing, so I'm going to wait a sec. All right, last one says, this coat hanger is 5 feet long. Which box below can I use to pack this? Now, before I do anything, what do you notice? Inches and feet. You need to decide, do you want to work in inches or do you want to work in feet? It's up to you. You want to work in feet? So I saw Carter say feet, so I'm going to do what Carter says. If you want to do inches, convert all the feet to inches. We're just going to convert the inches to feet. So right here, 24 inches is 2 feet. 24 inches, 36 inches, 3 feet. Okay, those are all feet. 30 inches. How do I figure it out?
2.5.
Divide it by 12, it is 2.5 feet. 24 inches and 36 inches. And what am I going to do with these answer choices? See which one's the biggest, or see which one fits 5 feet. So I'm going to apply the formula. Oh, it's not that hard. 2 squared plus 2 squared plus 3 squared. What is 2 squared plus 2 squared plus 3 squared? What's 4 plus 4 plus 9?
38.
Again, let's not answer incorrectly. What is the square root of 17?
I know, right? Straight.
4.1 something. Is that going to be long, the diagonal long enough to fit a 5-foot hanger? No. The diagonal is 4.1. Would a 5-foot hanger fit in this box?
No. So that means that 2 feet.
So right, if it doesn't fit in a 2x2x3, is it going to fit in a 2x2x2?
No.
Probably not. I mean, you can still do the work to check it. Probably not. Try these last 2, go. No. What is that?
5.1.
Yeah, I got it.
9, 6. I did my something. Isn't rice looking expensive? Let's go.
What?
The college, is it like really expensive?
Is college really expensive?
No, the Rice University.
Rice University is very expensive. It's a private college. All right. I want to mention something because last period somebody's like, Miss Olivares, why can't we just choose the biggest box? Sure you can. But what if there was more than one answer and it wanted you to figure it out? Miss Olivares, we'll just choose the 2 biggest boxes. Great. Okay, so just something to think about in a question like that. Common sense does go a long way as well. Great? All right. But we don't know if there are multiple answers, so always check all of them just in case. I would like you to glue this onto page 47 in your notes. We're going to call it Diagonals of Prisms. You have a Schoology assignment. Again, you must show work.
All questions?
Yes, all questions. It's 10 or 8, I don't remember. But I just want to show y'all some of y'all's work. I want to shout out this person. I won't show your names, but maybe I will show your names. Let's see. Do you see how organized this work is? Do you see how I can see every single answer and what problem it goes with? Beautiful. Okay? This one doesn't even have a name on it, but I like it. I will say I would prefer if you boxed your answers because it can kind of, like up here you did, and then you stopped. I would also prefer if maybe you left a blank in between each one because this is kind of just cramped. Do you see how it's kind of hard to find things? All right. This one, beautiful. This one, beautiful. This one. Again, is it boxed and everything like that? No, but I can very clearly see each question. Okay? I can very clearly see that. This one is kind of on the fence. I can, but it's still a little bit of, maybe space out a little bit. Alright? This one is beautiful. Maybe space out a little bit. Okay? Alright, this one's definitely too cramped. I'm getting old. Alright? This one, great. A little cramped, but great. This one, perfection. Alright? I really like this one. Maybe a little bit more space. Or like you box some of them. I mean,
That one's not pretty.
I think it's fine. I can find, literally, here's question 4, here's the answer. Here's question 11, I can find everything very nice and neat. It's a little cramped. Hold on. I got the one I want to talk about.
Oh no.
Again, that one maybe, that's not the one. That one maybe, box your answers. Oh wait, where'd it go? I put it off to the side.
Bitch, you said mom was cute. Thank you, bitch. Oh, okay.
What problem number? I see a bunch of things circled, but like.
Damn, son.
Logan, what is wrong? Just give me an opportunity to redo it.
Make tonight's nicer. It was your first time.
Is that Logan?
You should have seen.
Make tonight's nicer. Don't do this again.
Gosh, Miss Shang would have speared him.
Well, like, what is, what?
Oh my god.
I can follow the word, but like, what problem is it? Where's your boxing? Where's your, organization? Make my life easier and makes your teacher happier. Let's do that.